Okay, let's try this lesson 2-2 here, the standard form of a quadratic function. So if we have a quadratic y equals x squared minus 3x minus 18, and we're being asked to find the vertex. In case you forgot, to find the vertex, the x value can be found in the book. It shows you this formula and how they came about it, but negative b over 2a. And then after you solve that, so right here we have an a. If there's nothing there, that would be 1. We have b here of negative 3, and this c of negative 18. In case you forgot, that's where they come from in the standard form. Standard form ax squared plus bx plus c. So once you evaluate this negative b over 2a, in our case here, that would be negative b. B's already negative 3. So when we do this negative on it, it's going to be a positive 3 over 2 times a. A is 1. So 2 times 1 is just 2. So we have 1.5. And then to find the y that goes with that, you just plug that into the original problem for the x's and work it out. So let's see, that would be 3/2 or 1.5 if you want to use decimal. If you want to use fractions, that's fine, however you want to do that. Squared minus 3 times 3/2. Look at, I'm mixing decimals and fractions. That's crazy. All right, then minus 18. So if we did this 3/2 squared, square the top, square the bottom, that'd be 9/4. And then minus this next one is 3 over 1, so that's 9/2. Multiply straight across, 3 times 3, 1 times 2. And minus your 18, or 18 over 1 if you want. So let's see. This, and then if you want to change it to decimals at some point, whatever. Because like this, 9/4, that's 2 1/4. 9/2, that's like 4.5. So 2 1/4, 2 1/4 is, so this would be a negative 2 1/4. And take off another 18 and we end up at a negative 20 1/4. That's a not real nice number, but I suppose it could be worse. So I was going to put this in decimal here. Could leave this as the 1.5. Now, from what we saw in the last lesson, if we know that, we could put this in our graphing form of x minus your 1.5, or sometimes called your vertex form. I think this book calls it the vertex form. Now, do we need a stretch factor out in front of this whole thing? Since this was a 1 up here, then we don't need a stretch factor because this will have a 1. So right here, we would have our vertex form of that equation. Let's see, what else in this lesson 2-2 would you need to have? Can you find the vertex, the axis of symmetry? So the axis of symmetry, all that is when you have an equation and you've graphed that parabola, that quadratic, and you have a vertical line that would split that parabola right down the middle. All of the x's are the same number on that vertical line, so the equation x equals, and it has to go through the vertex. So in this case, we went through a positive 1.5, so x equals 1.5, 1.5, 3/2, whichever form you want to write that in, for our axis or line of symmetry. So axis of symmetry, line of symmetry means the same thing. It's that y equal, or the x equals negative b over 2a. The y-intercept. So on our y-intercept, oh my goodness, this page is getting full of good stuff. The y-intercept, x equals 0 on the y-axis. So when you plug a 0 in for these x's, this number at the end is all you have left. So that number on the end is always going to be your y-intercept. You know, some people don't like you to just list it as a number. So know that sometimes you'll run into somebody that says you got to write the ordered pair. I would contend it needs to be that they ask you for the coordinates of the point of the axis of symmetry. If they just say, what is the y-intercept, I think it's okay to just list that number. Then obviously you have points on each side that are symmetrical because it's a parabola. And if we were to sketch this graph, oh my goodness. So we had our vertex at this 1.5 over here, down negative 25. It's going to open up. We knew our y-intercept in this case was negative 18 over here. And you could label that vertex there as well. So that's a whole lot of stuff in that problem. What if they gave you an equation and they just asked you, let's take this exact problem. So that they're going to give us a formula for a function, and this one specifically says f of x equals negative 10x squared plus 700x minus 7,000 minus 6,000. It goes on to say the graph, and it's given, looks sort of like this. It's a parabola opening down. This right here is at 10 for an x-intercept, and at 60 over here, and the vertex looks like it's maybe at about 35. Maybe it's 30. It seems like, no, 35. That would be 25 away there and 25 away there. So 35, and it goes up to a max height just above 6,000. So 6,000's here. I don't know what that exact number is for the vertex, but this is a profit of a company based on the selling price of an item. So you might ask yourself, well, why is the graph even that shape to start with? Well, down here where you start out, you're not selling it for anything, so you're not making anything. And as you sell it for just a little bit more and a little bit more, at some point in here, you reach the sweet spot where you're selling it for a price and people are still buying it. But what happens on the other side? Overpriced, and people quit buying it until eventually over on the other end, nobody's buying it, so you still don't make any money again. So that's why the graph gets shaped like a parabola in supply, demand, pricing, and the profit. So the question would sort of like be here, what's the best price to sell to make the most profit? So what's the selling price to get the most profit? And wouldn't that just be like finding your vertex? So how do you find your vertex in this problem? Do you remember from the last example? Negative b over 2a, that's the axis of symmetry, with an x equals in front of it, so that would go through your vertex. So what is the b in this case? 700 divided by 2 times a, negative 10. There's your b, the a, there's your b up there. So that would be a negative 700 divided by negative 20. It's going to be a positive, and 2 goes into 70 35 times. So the selling price, 35, that's what we said it should be over here. But how do we find out what the profit is that we'd get from that? Again, do you remember from that last problem? We said, what do? Plug it in for your two x's over here. So negative 10 times 35 squared plus 700 times your 35 minus your 6,000. And then I would recommend just crack-a-lacking that on a calculator. Be careful with those negatives. I'm going to put the 35 in parentheses and a squared outside the parentheses. And then the 750 times the 35, just use those parentheses. And if you type it just the way it looked, I came up with an 8,000 for that. If I remember right, I looked at the graph and I told you it does not look like it's 8,000 to me. Did I copy something wrong? I've got my negative 10x squared, 700x minus 6,000. And look at how I typed it in my calculator. Oh, I typed a 750x. Now, where in the world did I get the 750 from? Let me fix that. Change that. Try that again and get 6250. See, if you go back and check your work and look at the graph, this number right up here was just above 6,000. 8,000 was up here, and it didn't look anywhere near that. So, 6250 found my typo by just taking a second look at my work. All right, what if you had another problem that said on this one that you're going to throw a water balloon in the air, and the water balloon follows the path. Y equals negative 16 x squared plus 160x plus 50. So the water balloon, x here, x is your time in seconds, and the y is the height in feet of the balloon. So at zero, because if I put in a time at 0, those x's are 0, these parts go away. I just have my 50. It's going to start at 50 high from the beginning. It then is going to go up, come down, and here's where it hits the ground. So obviously there's this little piece over here too that isn't on the graph. So the ultimate question, what's the maximum height of the water balloon and what time does it happen? So we're looking for the vertex. My time that it happens, the maximum height. So how do you find the vertex? Same thing we did on the last two problems. Negative e over 2a, that'll give us the axis of symmetry going down there through the vertex. So a negative b, b 160, negative 160 over 2 times a. There's your a, negative 16. That would be the time that I'm at that maximum height on the vertex. So let's see, this 16, this 16, go in there and leave a 10. That 2 goes into 10 and leaves a 5. So it looks like it's at 5 seconds. You can actually work that out if you'd like to, just check and see. And then how do we find what the height is when they're at 5 seconds? You put that 5 up here and here for your two x's. So negative 16 times 5 squared plus 160 times that 5 plus the 50. And again, see if I can do this one without making a mistake. Negative 16 in parentheses 5 squared plus 160 in parentheses of 5 and plus a 50, and I'm seeing a whopping 450 feet. Are you serious? A water balloon can get up? You must be doing that with one of those launchers, those water balloon launchers. It says it's coming out of a window 50 feet high. I guess that makes sense. But that would be another example of how you could do that problem. think we'll skip the problem on the matrices. If you want to know how to do that, we could go over that in class. I think I did an example of that at the end of topic 1 in lesson 6. So you could go back and look at that one if you'd like to know how to do that. The last thing is how can we do a regression? And so to do a regression, a quadratic regression, if you have a graphing calculator, it's one thing, but if you're going to use Desmos to do this, I'm going to recommend you go and just watch a video on Desmos that shows how to do a regression. A regression is where you have several points of data. So if I have a table of data and you can run the program, and what it's going to do is it's going to calculate on these points the difference in the distances between them. And then it's going to, based on those, be able to tell you with what's called an R or an R squared, the regression, how close the equation would match all the data points. Because it can't be a perfect parabola, but it will be somewhat close. And with that, I think I'll have you guys get started on the assignment.